Over the years, we have observed how customers have been modifying the engine to suit their needs. So we have been working to improve how we build the engine and how we provide a better developer experience. This doesn't necessarily mean that it's the only way, especially with O3DE. We start seeing that there are customers that want to see the engine quickly, so they want to jump quickly to an editor and start like building games or building some project. So we are working on improving those workflows, and I'm going to go through some of that today. My name is Esteban Pap. I'm a senior SDE at AWS, and I have been working in O3DE and before that in Lumberyard. And I'm going to present how we build the engine and the project. So before diving into the different ways that we can build the engine and the project, I'm going to go through some basic build concepts and some concepts related to the tool that we use to do the building, which is CMake. So there are three parts that it's important to understand because we refer to them while talking about how to build it. One is the engine. So what do we call the engine? It's a little bit like ambiguous because we call the engine basically the building blocks that O3DE provides for everyone to build their projects. So you can think of the engine as everything that is in the O3DE repository, but there are certain things in the O3DE repository that are not specifically the engine. So for example, we have a project inside there called automated testing, and that project is used for test regressions and other kind of testing in continuous integration, etc. And we also have a lot of test modules inside the engine. And those are actually not part of the building blocks that you will use to build the project. However, they are shipped within the O3DE repository. We also have the concept of gem. If you want more details about that, go to Colin's talk. He's going to be talking more about that. From our point of view, gem, it's a way to extend the engine. So it's kind of like a way to create a plugin that will extend the engine. And that gem can be either functionality or it could also be assets, for example. And it doesn't necessarily mean that the gem has to be just a module that extends the engine. You can also put other stuff inside there. But the way that it plugins in the engine, it has to be through one of the defined ways that we have to do that. And finally, project is what we call to the thing that you're building. Because this was originally a game engine, you will see some concepts mixed there between project and game. But because now we want to cover other things besides games, it becomes more flexible to call it a project. So basically, project is what you are building. Now, regarding CMake, I'm not going to dive into a lot of CMake. I'm going to dive into that a little bit more in tomorrow's presentation. So I will go superficially over some concepts here. So CMake first is not a build tool. CMake is not going to perform the build. CMake is what is called a project generator. So what it will do is it's going to generate build scripts that a build tool is going to use to build. So the first concept is generator, and basically the generator is the build script that we are going to build for. So for example, in Windows, you can generate for Visual Studio, and that will generate build scripts that then you can use to build. The name Visual Studio for that generator is a little bit misleading. It's actually generated for MS Build. It just happens that a Visual Studio then uses MS Build to perform the build, but you can also build from the command line using MS Build directly. And then we have the concept of golden path that we have been, probably you have heard about it in Discord. Golden path is the options that we have selected for each platform. The reason to do this is that it will get very complicated to support all the options that CMake provides. So to give you some numbers, CMake in Windows has like 39 generators. And if you consider 3 compilers, like if you take GCC, Clang, and the Microsoft compiler, you take 3 configs like debug, release, and profile. Those are the configs that we have. And you consider monolithic and non-monolithic, you end up with like 700 permutations that you will have to test and validate that are working. Because that will involve a lot of infrastructure costs, and also it will require developers to keep that working Imagine that you have to do a change and you get some of those permutations failing. It will take you a long time to go and fix it. So in order to accelerate all that, what we are doing is defining for each platform a golden path, which is one generator and tool chain. So for example, in Windows, we define the Visual Studio generator and the Microsoft compiler toolchain. This is open for discussion, especially now with O3DE. These decisions don't mean that have been right. We have taken this decision some time ago when we were at Lumberyard. So please open discussions in Discord and GitHub if you think that we should take another golden path. Then for CMake, we have 3 different ways to configure CMake. So CMake, you have to pass the basically where your CMake scripts are, and that is the source directory. Basically, what you're passing is where the root CMake list txt file is, and that is the source directory. So basically, that is your input. Then you're passing the build directory, which is where it's going to dump those build scripts. Because CMake is that project generator, you have to indicate where you're going to put those build scripts and build from there. It also happens that that's going to be the folder where the binaries are put, but mainly it's the folder where you are putting your build scripts. And then we have cache variables, which is how you pass parameters to CMake. So if you want to define inside your CMake scripts a way to receive a parameter that generates things in a different way, you can declare a cache variable and then pass it through the command line or through the GUI. And that is how you parameterize your generation. And then we have the concept of target. We are going to use that a little bit, so I included here. We call target basically libraries, executables, anything that we produce with the build system. So high level how CMake works, we basically feed the source directory, and that is the root CMake list txt. That file ends up including other CMake list txt files, and we run CMake indicating a generator, and that is going to generate the build scripts that we are going to use for building. So for example, in Windows, we can be generating VCX proc files, which are MSB files that Visual Studio uses to build. We can be generating Ninja files, or we can be in Mac, we could be generating Xcode proc files, which is what Xcode uses to build. Again, the thing that we use to build is not going to be CMake. It's going to be a native build tool. So for example, MSBuild in this case, you can use Visual Studio, and Visual Studio invokes MSBuild, or you can use a wrapper that CMake provides, that is CMake build, and that under the hood calls MSBuild. But again, CMake is not going to perform the build. And that is what's going to produce the outputs, the X's, DLLs, etc. There is one important thing to be aware about CMake generation, which is the zero check project. So CMake, what it does is it generates a zero check project that is going to be the one tracking if you change or not your CMake files. So the idea here is that every project depends on this zero check project. And when it runs, for example, in Visual Studio, it's going to check, the zero check project is going to check the timestamps of all the CMake files. If any of those files change, it's going to regenerate. It's important to understand this because different IDEs have different behavior how they perform this, and most of them have some issue around it. So for example, in Visual Studio, because Visual Studio keeps the VCX proc files in memory, what happens is that you perform a change in CMake, in some CMake script, zero check it runs, but it's going to keep building with the version of your Visual Studio projects that are in memory. So you're not going to see those changes until the build finishes. And you are going to notice this because the build finishes and says, the files were modified outside the environment. Do you want to reload? You hit reload. And if you try to build again, it's going to build again, depending on the change that you're doing. So say, for example, that you're modifying a flag that affects the whole build. If you go then and build, you're going to see the regeneration, and it's going to build everything. And then if you, when it ends, it's going to reload. Then you go and build, and it's going to build everything again. So to prevent this, what I do is after I do a change in a CMake script, I just run the zero check project. That leaves the project clean, and it's going to reload there. And then I go and build the target that I'm interested in. If you're doing it from the command line, that doesn't happen, so that is also safe. If you are in another platform, so for example in Mac, Xcode has a similar thing. In Xcode, what happens is that the zero check modifies the project, and then it basically causes an abort on Xcode. But that is not very obvious, so you have to just be careful with that. So now into the workflow. So we have two main ways, or different ways of seeing what you're building and how you're building. On one side, we have what we call engine-centric, which is we are building from the engine point of view. So basically, in an engine-centric workflow, we are giving the engine as a source there to CMake. And what happens under the hood is that the engine includes the CMake scripts from the project. And then we can build that way. So basically, for CMake, what you need is for the engine to find the project, to include it, and then that will bring all the project targets into your CMake environment for you to build, or for you to generate the solution that you are then going to build. So how do we do this? We configure CMake, we pass the source directory as the engine path, we pass a build directory. You can pass actually any build directory. What we do is we put the build directory inside the source there, so that way you know where it's coming from. And we have excluded the build directory from Git, so that way you can put multiple build directories inside there. That is another important thing. You can have multiple build directories per source directory. And then you indicate the generator. So the generator, in the case of the CMake GUI, is going to ask you for the generator the first time, and then it's going to put it there. It's going to bake it there in the UI, and you cannot change it. If you want to change it, you will have to do something that, like deleting the CMake cache txt file. And then lastly, you pass the projects that you want to build. So you pass it with a cache variable. So the -d is how you define a cache variable. And in this case, we are defining ly projects. The ly underscore is because this was written when we were back in Lumberyard. And by putting that prefix with an underscore, it organizes it into the UI that way, like you can see there in the image. And you can pass the projects that you want to include into your generation. This is one of the main benefits of this approach, is that you can pass, you can actually pass no projects. And that is something like, for example, if you're working on a unit test in the engine, you don't need to build a project. Or you can pass multiple projects. That is not very common, but it's a workflow that it's supported and we can use it. The projects are paths relative to the engine, or you can also pass absolute paths, and you can also intermix between them. And then to go and build, again, you can use Visual Studio or MS Build, or you can use this wrapper. This wrapper, it's very convenient because it abstracts you from what build tool you're using. So you don't have to remember all the build parameters that you have to pass to each tool. And you indicate the builder that you're passing, the configuration. So that is if you're configuring, if you're building debug, profile, or release. The target that you're building, this is very important because as I was saying before, O3DE has a lot of other things that are not specifically the engine. So, so if you build everything here, you're going to be building test modules, test tools, and other stuff that you're likely not going to need. So by defining a target of what you want to work on and what you want to build, you reduce the amount of building that you're going to be doing. And then you can pass any native build parameters with at the end. And that is what makes it very obvious that we are calling a native build tool here. So for MS Build, we recommend to pass /m to build everything in parallel. Now, the other way of building is to see it from the project point of view. And in the project-centric, what we do is, instead of passing the engine as the source there, we pass the project. And what happens is that inside the project CMake files, there is a logic there that is going to find the engine. and then the engine is going to end up including the project again. So the part of engine including the project is the same as if you were going to do an engine-centric and pass the source dir to the engine. It's the same path. And in order to avoid loops there, we have an if-else that basically breaks that condition. So the project is going to find the engine. We're going to see how that happens. I'm going to go through one method of how that happens, and if you're interested in the other method, I think Darius' talk is going to cover that. So to configure that, we basically define the source directory to be the project path, the build directory, basically whatever we want. And in this case, again, I'm going to put it inside the project path, generator the same, and this is the trick part, or the difference, how you pass where to find the engine. So here I'm using just a cache variable, which is like the most direct way to define that. It's not the recommended way, it's just that it's very obvious to show it this way. So here we are passing the engine path slash CMake, and we are pointing to where the engine source is. So you can see here the path O3DE slash CMake. So the reason why we are passing the CMake folder is because the find file that is used to find the engine is in that folder. The other way is if you don't pass the CMake module path, what will happen is that the project CMake files are going to have some logic there that are going to go and find the engine path for you and add it to this variable. And the way that it does it is that you define in your project what engine name you're using, and then there is a map there that says this engine name maps to this path, and that is through the registration process. And then to build, it's very similar to before. You just pass the builder. In this case, it's going to be a builder that is inside the project. You pass the config, you pass the target, and everything else is everything is the same. Now, the benefit of doing a project-centric is that we said that the benefit of the engine-centric is that you can actually pass multiple projects or pass no projects. In the project-centric workflow, the benefit is that you can select different engines. So you can, for example, let's say that you are modifying the engine and you want to see how your new version of the engine performs. You can actually make your project point to one, profile it, and then point to the other one and profile it and compare. And another benefit is that we can actually generate a version of the engine that instead of having all those targets declare and saying like, I have to build all these things, it exposes the same targets but already built. And that is what we are doing with a process called CMake install. We are generating a version of the engine that has CMake script files that look exactly the same as they were in the engine source, but instead of building, they are what CMake calls importing those targets. So to give you an idea, basically in the engine source, you will have like the declaration of a static library saying, these are the CPP files that you're going to compile with these include headers, with this include paths, and this defines. In the SDK generated CMake script, we have a similar declaration, but instead of saying these are the CPP files, we just say this is the static lib that this target represents. And then to use it, it's exactly the same. The project is going to find that SDK, and then the SDK ends up including the project, and we get to use that way. So how do we generate that SDK? Basically, what we want is to do an engine-centric here. You can actually generate an SDK out of a project-centric. It's the same, but likely you don't want to put your project into the SDK, but you can. So to generate the engine, what we do is we look at it from an engine-centric point of view. We pass the engine path as the source dir, build directory the same. We pass the generator, and we don't pass any project because we don't want to put any project into the SDK. And we have two variables that we recommend using. One is to disable the test modules because you also don't want to put all the test stuff inside that SDK. And the other variable that we have is the ly version engine name. And that is, so if you're going through the registration of the engine part, so if you want the project to be able to switch between one engine or the other by using registration, so by using that name that you're seeing there, you can also change the name that we are going to export the SDK with. So you could also generate different SDKs with different names and then make the project choose which one to use by just using that name. I personally don't use that because I like to pass explicitly what engine I'm doing because I have a lot of different engines going on at the same time. But this is the default way and the recommended way. And then to build the SDK, you basically pass the builder, that is the same. And then there are two important parts here. One is the config. You have to define which config you're going to generate the SDK for. We already support, so we already did changes to support multiple configs in an SDK. So you can right now go and build this like 3 times and get the 3 configs into your SDK. But likely the config that you will want in your SDK, it's profiled because that has the editor, that has all the tools, and that has everything for you to work on. The release configuration, we have been using that historically for releasing the game. So that is like the final version of the game. And the 2 downsides that you're going to have there to be able to use it as an editor is that first it removes all the logins. So you're not going to have errors or hazards or any warnings issued. And the second problem is that release uses packs. So that means that you will have to generate the packs in order to use it. And the second part is that what you're building. So CMake generates a target called install. And basically what that target does is it's going to build everything, and then it's going to run a CMake script that is going to generate all the other stuff that we want there. So all those CMake scripts that wrap that build result, it's going to be run in that CMake script that gets generated. And you can actually inject more things there. So we have a whole file there where we inject different things that we want generated at that state. And if you want to change where you're going to generate that, that SDK, you can define that with the CMake prefix path. So basically, this install process is going to generate a layout folder that is going to contain all the binaries and all the CMake scripts seen in a way that if you go and include it, you're going to get those targets imported into your project. And then to generate the project for your, the solution for your project, it's exactly the same, except that instead of pointing to the engine source, you're going to point to the engine install path, to that prefix path that we passed in the previous, when we were generating the, building the SDK. So here, I basically generated into the default, which is /install. So here we just have to pass O3DE /install /CMake. And again, you can also use registration, and that is the recommended way. So you can actually go register the engine that is in that install path, and then go to your project and just say, I'm going to use that engine, and just make sure that you match the names of them. And then to build your project, very similar to before, you pass your build directory, you pass your config. Important here that you cannot build a config that is not in your SDK. So if your SDK only has profile, you cannot go and build your project with debug, for example, because there won't be a match in there. And another important thing is the target. So you cannot go and build something that is already built. So here what you want is to build something like the game launcher or some gem that is inside your project. So here, for this particular scenario, I would recommend to not passing a target, because it's very likely that what you want is to build everything in your project. So it becomes simpler to just not pass a target there. In the other cases, I don't recommend that because you're going to end up building more. But in this case, your project is going to be rather small, and everything that you want, that you put in your project, is likely something that you wouldn't want to build. Another benefit that we have with the Project-centric is that now we can grab that SDK that we generated with the CMake install process and package it into an installer. And then you can distribute that installer and install it in other machines and basically get that pre-built version of the engine. And that's what we are doing with this installer that we have released recently. And then for finding that, it's exactly the same. So the project, we indicate the project as a source dir that finds the SDK that was installed. So here what we are going to see as a difference is that instead of passing the path to the engine source, we're going to pass the path to where we have installed that SDK. And then the SDK ends up including the project. That's the same. So here, the only difference is that we are passing in that CMake module path, we are passing here O3DE underscore 0.0.0, which is where I have installed the engine, slash CMake, that's where the find file is. Again, you can also use registration, so you will go to that folder and run O3DE or some registration script to get that engine registered, and then you can just refer to that engine by name. And then to build is exactly the same as a project-centric engine pre-build where you build the SDK. So the same things with config and target. Don't pass target, that will be the recommended way, and config has to match what the SDK was generated for. If you are using something like Visual Studio, you will see only the configurations that are available for that SDK in your project. So for example, if you just generated a project with, you just generated an SDK for profile, in your project, you're just going to see profile in the drop combo box of the configs. So now I'm going to switch, sorry. I'm going to switch here, and I'm going to walk through some of these workflows. So let me just. Okay, so what I'm going to do first is I'm going to show you how I generate an SDK. So I can just, I'm going to create a new build directory where I'm going to put things. So we're just going to call WinTest. So I just created a folder. I'm going to do it through the CMake GUI, so it's easier. So here we are just going to indicate that we're going to put the, so the source directory is the O3DE in the E drive, and we are going to put the build scripts into WinTest. So here we are just going to pass WinTest, and typo there. And we want to define, so here I'm just going to go and generate, so it's easier to find, nope, another typo there. WinTest, okay. So here I'm just going to go and generate, yet another typo. So here I'm just going to go and generate, so then we can go and modify the variables. So here I'm going to indicate the generator, and you don't need to change anything else. You can actually build for choosing another tool sets or another platform. You can go and see those options in the CMake documentation. So here I'm just going to run the generator. So the first time it's going to do two things. It's going to run configuration, which is this first part where it detects compiler and other stuff. And then it's going to go and run our CMake scripts. So I already downloaded all the third parties, so this is going to go faster. And tomorrow I'm going to dive a little more into the third party stuff. In the meantime, I'm going to jump into a project. So I have a project here that I have been building and playing with. So in this project, what I'm going to do is I'm going to generate project-centric pointing to the engine source. So you can see what it generates there. So to do that, we just go to the CMake module path that I have here, and I'm going to point it to the engine source. So we hit generate. This will take a little bit longer. The other one is still going. And once this is finished, what I want to show here is that when you open the solution here in Visual Studio, you're going to see not just your project, but you're going to see also all the targets that are in the engine. So you're going to see all the test modules, all the libraries that are in the engine. So the configuration finished here, so that means that it already parsed all the CMake scripts, and now it's generating the project and solution files for that generator. Let's see if the other one finished. Not yet. This takes around 50 seconds. And I'm not going to go through the build process. I'm just going to issue one build so you see that it goes through. But I already pre-built it, so it's going to take a couple seconds there. So now that this finished, I'm going to open here you can open the solution. It's going to load that. So you can see that it's loading a lot of targets there, so around 469 projects. And you can see here that you see all the projects and all the files in each project. So you see all the libraries that are part of O3DE. So that is also another benefit, is that when you use the engine source, you get to see all the engine. So it's easier to debug, put breakpoints, and work with that if you are working inside the engine. So if you are modifying the engine or extending the engine somehow, it's easier to work this way because all your changes get built automatically with your project, and it's easier to debug it and work with. So now let's switch back. This should be done. So now that we have the project for the SDK, I'm going to go and build it. Instead of building it in this folder, which is the one that we just created, I'm going to go and build it into the one that I already have. So basically here I'm saying build this folder for profile and target install and /m because we are in MS Build and we want to build in parallel. So this basically I already configured this folder and I already built it to generate the SDK. So here we will be generating the SDK. So this is going to go fast because it's already pre-built, and it's going to take some more time at the end running that install script that we generate during the process. And then once that finishes, what we are going to do is, so here we are in the project and we see that the project is using the engine source and it has all those targets from the engine. So I'm going to switch this project to use an engine pre-built, to use that SDK that we generated before. So I'm going to go to the project, and the only thing that we need to do is change this module path to point to where we are installing that engine, which is in the default, which is the engine/install. And we have to pass that CMake because that's where the find file is. So we generate that. Hopefully the other thing finished, so we are not doing the same thing. So now if I go back to the project and it's telling me that the project has changed externally, so I hit reload here, and you can see that it went from 469 projects to 14. So now we have the project that is looking at the engine pre-built. And we have added things like, we have added this dummy target, the editor, here to just indicate that, so that editor dummy target, what it does is it's just going to call the editor passing the project path, so it's easier to just launch the editor from here. So something else that I wanted to show you here, like you can see here that the only config available is profile, and that's because we generated that SDK just for profile. So I just built it for profile, and that's why you're seeing just profile here. So if you go and launch, I set up editor as the startup project, and you launch it, you're going to get the editor up and running. And this is the editor running in Project-centric with the engine pre-built. Great. The right thing. Yeah. Okay, let's load it there. Okay, I probably did something wrong here. Likely I didn't finish this install process before building, so we are going to leave it there. I have a mix here between the project build with the engine source and the project build with the engine pre-build, so it could be something related to that, some configuration there going on. Okay. Okay, that's all. Thank you. And if there are any questions, please post them in the SIG Build Discord channel, and I'm going to try to go through them.